So in today's class, we are going to study the next concept is moment of inertia of perpendicular and parallel axis theorem. So you can keep heading perpendicular and parallel axis theorem. Okay, and the numericals related to that. So this is also one of the most important concepts. So this H.C. Verma and Pandey, Desi Pandey books, this all the books we can, this all the numericals also related to these concepts. So this is very important concept. So please make sure that. So first you keep heading perpendicular axis theorem. Okay. So what is this perpendicular axis theorem? And everything will make it. So remember, perpendicular axis theorem is only applicable for two-dimensional body. So body which is a two-dimensional is only we are going to use this one. So all of you observe very carefully. Let me take any kind of random body. So I have taken a random body now. So if I take x-axis, so this is the x-axis, and imagine that perpendicularly. That's what video I have shown you already. So I'm imagining a perpendicular axis which is acting. So what is that axis, everybody? Z-axis, perpendicular to the plane. And imagine that then y-axis will act what? So this is what, see, that's what three-dimensional it is difficult to show. So this is what is the axis, everybody? It is the y-axis. Are you clear, everyone? So this is what is about x-axis, z-axis, and y-axis. So perpendicular axis theorem, basically it will be work for two-dimensional one. That is what we can take it as a like lamina or a plate, two-dimensional plate, where the thickness is 0. So keep it in, everybody. Thickness is equals to how much? Thickness is how much it is? 0. Okay. So what is this perpendicular theorem? Perpendicular axis theorem. All of you observe very carefully. So the moment of inertia in z-axis is equals to moment of inertia in x-axis plus moment of inertia in y-axis. So this is only called as perpendicular theorem, perpendicular axis theorem. So please note it. So what is the required conditions for this perpendicular axis theorem? Conditions required, the things. First one, x, y, and z. All three must be what, guys? Perpendicular to each other. So x, y, z should be perpendicular, should be mutually perpendicular. So this is the first condition for perpendicular axis theorem. Next, x and y axis should be in the plane of the body. Now you understand the video what I have sent, everybody? Plane of the body, x and y must be on the plane of the body and z must be perpendicular. Are you clear what I'm saying, girls? All of you? Next, z must be perpendicular to the plane of the body. That is what is the third one. So z should be perpendicular to plane of a body. So these are the three conditions required for the perpendicular axis theorem. So what is perpendicular axis theorem, everybody? Momentum in z-axis is equals to momentum in x-axis plus momentum in y-axis. That's all. Understand? Pradosh? So that is what it is about it. Now let me take a point. See, this total mass is, let me take m. Okay, the total mass is m. So I will choose a particular mass. So what is the small mass, everybody? Let me take, this is the small mass. So what is this mass, everybody? Small mass I have taken. Please respond. What is the small mass?
dm.
So this dm is actually x distance. So from the x-axis, this is x-axis. So this is the x-axis, x distance. And this is the y-axis. Imagine plane. I'm imagining a plane it is. So y-axis. So like this is what is our x-axis. You can notice it. And this is what is our y-axis. Now, I want to find it. So imagine this is the xy plane. Object is in xy plane. So you can imagine xy plane means video I have shown you, correct, in that xy plane. So object is somewhere here. So which is in a y-axis, some y distance. See that y-axis. This is the y. Be very careful. This is the y-axis and this is the x-axis. Is it okay, Rudreswar? For imagine like this point is 2 and this point is 3. So the point is what? 2, 3. That's what x and y. So now let me take this particular point. What is the momentum in x-axis and what is the momentum in y-axis? Can you tell me first what is the momentum formula? Momentum I is equals to what? What is the formula of momentum? M into what, guys?
3.
M into
R square.
R square. Are you clear, all of you? So that is what we have to do it. Now see, so this is the x distance, x-axis, and this is the y distance, y-axis. Now if you notice it, I want momentum in x-axis. Can you tell me this particular particle? So this particular particle, dm particle, what is the momentum in particular x-axis is equals to? Mass is dm, and x-axis how much far away? Have you checked it? How much far away it is, x-axis? How much far, guys? From the x-axis, r. So r means from the center. This is what? So this is
Y
actually. So how much it is? Y square. Next, same way in d in y-axis, how much far it is? How much far, Dresha?
dm x square.
Yes, dm x square. So that is what it is. It is. Now we want moment of inertia in z-axis. So what is the z-axis formula? Sum of the moment of inertia in x-axis plus moment of inertia in y-axis, which is equals to what, everybody? Dm x square plus dm, please respond, dm y square.
Y
So
Y
if I
square.
make this one, so dm is common. Dm, now you can see that x square plus y square is equals to something. Triangular, you know, two sides. Then hypotenuse, which is equals to what? All of you? So this is, let me take x square and this is y square. Then what will become this one? So this is x and this is y. Then this will become what? Everybody. Yes, please. Let me take r. That is what radius you can take from the center of mass. Actually, this is COM. From the center of mass, this will be r. So what is that Pythagoras theorem if I apply? R is equals to what? All of you. Root over x square plus y square. R I can take r square is equals to x square plus what? Y square. So instead of x square plus y square, what I can write, guys? Everybody? What I can write? Dm into
R square.
r square. So this r square means what? X square plus y square. So this is only called as moment of inertia in z-axis. That is what z condition. So that is only called as actually what, everybody? Perpendicular axis theorem. Now this is for particular particle. So this one, it contains infinity number of particles. So many particles is present. So what we have to do it, guys? If you want to find it, we have to apply that
Integral.
what for this one, everybody? Integration we have to apply. So integration of diz, which is equals to integration of di plus integration of dix. So this if you do, you will get it what? The total momentum in the perpendicular axis. Understand, Dresha? So this is only called as perpendicular axis theorem. So for finding total, we will use this formula. Okay, guys, please respond. All of you?
Yes, sir.
Yes.
So this is only perpendicular axis theorem. Perpendicular axis theorem means momentum in z-axis is equals to sum of the momentum in x-axis plus y-axis. That's all. Okay. Now xyz, if you remember, let me solve the question number 1 so you can remember. So let me take some kind of object. So x-axis, y-axis and z-axis is same. So what is this axis, everybody? Which is passing through the COM. All of you. Yes, let me take this is a disk. What is this, everybody? Disk. So having a mass m and r radius. Now can you tell me disk means? This already we have solved. Z-axis. What is the moment of inertia of a disk, everybody? Which is passing through the center of mass, perpendicular to the xy plane and passing through the center of mass. We have already calculated. See your notebooks and tell me fast. Yes, moment of inertia passing through the, everybody, Mr. Pradosh Teriyada, mr square by
2.
yes, mr square by 2 when it is passing through the COM and perpendicular to the plane. Check it, everybody. Now this is x-axis and this is y-axis. Now z-axis. So now we want moment of inertia and along the z-axis. So what is that? Moment of inertia and z-axis equals to moment of inertia x plus moment of inertia y. So now you can, everybody, all of you observe very carefully. We want what now? We know moment of inertia in z-axis. We want it now what? Moment of inertia in x-axis plus moment of inertia in what axis? Everybody. Moment of inertia in y-axis. Now, if a two-dimensional body, if you have taken here, If you cut it in x-axis or through y-axis, whatever it is, they look symmetrical or not, everybody? If it is the two-dimensional body, if I cut this one through the x-axis or if I cut through this one y-axis, the symmetry, the looks similar or not, everybody? Symmetrical? Yes, please. So if I cut it in any direction, x-axis or y-axis, so both appears to be what, everybody? Yes, please. They appears to be symmetrical. So
Symmetrical.
symmetrical means what? Ix is equals to Iy. So I will replace, so Iz is equals to Ix plus, I can replace Ix. So which is equals to moment of inertia in x-axis is equals to Iz. So what is Iz? We all people knows, everybody. Iz value what? mr square by 2, which is equals to 2Ix. So what is the moment of inertia in x-axis? Everybody, please respond. mr square by 4. So that is the answer. Okay. So please do it. So that is how we have to find the perpendicular axis theorem. What is the moment in x-axis? What is the moment in y-axis? If you want, you can verify it. Now x is same means y, then answer what will happen? mr square by 4 plus mr square by 4. So both 4 means what is that? 2mr square by 4. 2 ones are 2 twos are. Again, you got it in z-axis only. Have you remember? Have you got the answer, everybody? Please remember. Yes? Respond.
Yes, sir.
Yes.
So this is what is that? Any doubt? Anybody can ask. So this is actually disk. So disk means mass is only present on surface or it is distributed uniformly. Everybody, throughout it is. Disk it is. Disk. Mass is distributed. Am I right or wrong? It is not only on the surface. Yes, please respond. No, I don't know. If forgot means no use. You have to remember all the things what we studied last previous classes. Yes, Mr. Udreswa, Pradosh, understand? So this is
Yes,
the,
sir.
yeah, please solve it. Next question. So let me take a ring now. So we all people knows that. So ring means, so mass is only located at what? Everybody? Mass is only located at, please respond. At the surface. Okay. So then R is remains constant. So x-axis, and if I take y-axis now. So when the center of mass passing, so what is that? What is the moment of inertia? We already calculated. Z-axis. Yes, everybody. Perpendicular to the plane. All of you should say. So z-axis moment of inertia. Ring ra.
MR
What is that?
MR
Yeah. So ring mr square. So that's all. So we all knows that. So Iz is equals to Ix plus Iy. So x-axis or y-axis, I will cut it. It will be what? Actually, they are symmetrical. So symmetrical means it will turn. So mr square is equals to 2Ix. So moment of inertia in x-axis is equals to what, guys? mr square by, yes, please. mr square by 2. So that is what it is. So please solve it. So those understood? So perpendicular axis theorem. Perpendicular axis theorem means, Aswita, those who join late. So nothing else. Moment of inertia in z-axis is equals to moment of inertia in x-axis plus moment of inertia in y-axis. That is only called as perpendicular axis theorem. Understand, Aswita? That's what it is. So please solve it. Any doubt you can ask. Clear, Mr. Pradeep, Narayan, Kadri?
Yes, sir.
Yeah. So you must solve. Unless you try, you cannot be. That's the reason I told you to watch the video and then join in the meeting. So it is easy for you to understand. Are you clear, guys, this question? Any doubt, please let me know. All of you? Now, just I'm giving 10 seconds time. Already we have solved rectangular lamina. Do you remember, Mr. Udreswar, length into breadth we have solved? Rectangular, triangular lamina. What? Sorry, rectangular lamina and triangular lamina. I have already taught you the moment of inertia of a triangular lamina where axis of rotation is passing through the base. Do you remember, everybody? Yes, please respond.
Yes, sir.
Yeah, so you have to remember everything. Unless you remember, you cannot be. So now I'm taking a rectangular lamina. Sorry. Yeah, rectangular lamina. Rectangular lamina means all the sides are what? Everybody? All the sides are equal. So I take it equal. So now z-axis is passing through the center of mass, which is perpendicular to the xy plane. So perpendicular to the xy plane. Already we people knows. Anybody can tell me what is the z-axis? That is the question they are asking. So square lamina. So for plane we have already solved. So this is the square lamina. So can you tell me, everybody, what is the moment of z-axis? So options also I am giving. Everybody, see that we have solved for xy plane, not for z-axis. Check it, everybody. So answer is ma square by 6. Option B, ma square by 12. Option C, MA square by 4, option D, MA square by 3. So what is our answer? You can tell me. So just to see that this is what. So XY plane we already solved. Can you tell me what is the moment of inertia? in
A
X?
was sir.
Yes. Rudreswar? Yeah, answer. Very good. So already Rudreswar solved. So very good. So you have remember XY plane, we have solved it. Do you remember what is XY plane? If total is A means L case we have solved. Am I right, Ra? Yes or no? So L case
Sir.
means this will become what? L by 2, and this also will become what? L by 2. So here also it will become what? L by 2, and here also it will become what? L by 2. So instead of L by 2, here what will become? It will become what? A.
A.
By. So can you tell me what is the x-axis then? This is how much, Laksha, you got it? MA square by half. MA x-axis how much you got? MA square by 12. And y-axis you got it. I think you have written by the time B, so that MB square by 12. Am I right? Yes?
Yes.
Is length into breadth. So MA square by 12. That's all it is. So now we have given rectangular plane. So we want it in a z-axis. So x-axis we all knows. And y-axis also we all knows that. So y and x-axis. So Iz is equals to, what is the formula? Ix plus, brothers, no response at all. So Ix, x-axis, what is that? MA square by 12 plus y-axis also MA square by 12. So how much is the answer, Amma? Solve it, everybody. Which is equals to 2 MA square by
2 MA
12.
square by
So
12.
2 ones are 2 6. So what is the answer? Everybody?
MA square by 6.
Square by 6. That is the reason. So unless you solve the previous classes, already we have solved rectangular lamina, triangular lamina and all. So if you solve that only, it is easy. So option A is the correct option. Solve. Everybody solve. Simply listening and making, no use. Unless you solve, there is no use of studying 11th physics. And make use of ABC physics. I have sent you the books also. Please kindly make use of it and work hard. Any doubt, anybody can ask me. Are you understand, everybody? Yes?
Yes, sir.
So next, triangular lamina. All of you have a glance and tell me triangular lamina, what is the moment of inertia when it is passing through the axis of rotation is through the x-axis? I want to know. You should tell me all. Axis of rotation through the x-axis. We already have studied. Axis of rotation through x-axis. Yes, Mr. Dreswa, check it and tell me. Axis of rotation through x-axis. So triangular lamina it is. Okay. Triangular lamina. All of you see, we have drawn like this triangle, I think. Yeah, axis of rotation is passing like this. This is axis of rotation. So what is that triangular lamina? Moment of inertia. How much? I is equals to
Square by 6.
M. How much, Ra?
Square by
Square.
Yeah, MH square by 6 for height. Do you remember, everybody? This is all of you? Yes. Adi. That if you are not remembering, no use. So this is also X. Now different triangle. And this is also X. Draw neatly. Triangle you draw first and then we will proceed. Any doubt, anybody can ask me. So that you have to remember. That concept you remember only this concept, you can solve it now. Okay. So now you can see. So this is also y-axis also X and x-axis also X. So now I will use two words. You can see. If I put a cross, it is indicating that like 10th class, into the field and out of the field. Do you remember, everybody? Into the field and out of the field, out of the page and into the page. Yes, Mr. Rudreswa? Yes,
Yes, sir.
if I put a cross mark, it is indicating that going inside, into the field or into the page. Keep it in mind. Now, if I put a dot indicating that perpendicularly to the plane, but outside. Okay, wow. It is into the plane, going inside. This is also perpendicular, but into the plane. Now I am putting here cross mark. Now you tell me it is into the plane or out of the plane? Perpendicular to the surfaces. Into the plane or out of the plane? Everybody? Yes, please. Going inside. Clear, everybody? So for example, I will make you. So if you not understand, just have a glance. 2 seconds video, 2 seconds, just I will send a video and then you can make it. See, all of you remember, 10th class we studied into the page and out of the page. Do you remember? Thumb is acting towards the page, into the page, thumb is acting out of the page. Do you remember, everybody? That is only.
Yes,
So
sir.
now I will send the video, you can see. Now, if I make the into means, it is acting into the page. Like this, it is acting. If I make dot means it is the out of the page, like this it is acting. That is what perpendicular only. One is into the page, cross mark, dot mark means out of the page. I have sent you the video, just watch that video and then now we'll continue from this question. All of you make it. This is very important. Dot or cross. Brothers, I have both are perpendicular to the plane, but in going inside or coming outside, you can see that. Just make sure. Anything doubt, ask. Have you watched it? Shall we proceed now?
Yes, sir.
Yes, sir.
Brothers, that is what. So we have to find this now. So option A, mx square by 12. Option B, mx square by 6. Option C, mx square by 3. Option D, mx square by 4. So that is what is the concept. So answer please. So we all know that. See that this is also x only and this is also x only. Height also x only. So that moment of inertia and z-axis is equals to how much? Everybody?
See.
Yes, x plus and y. So please respond. What will happen? You all knows that x rotation and y rotation same distance. So same height. So what will happen this one? M h square by h means x here. Okay, wa? Clear? Yes, height is x. So mx square by 6 plus mx square by 6 y-axis. So what will happen answer? Everybody, 2mx square by 6, 2 1s are 2 3s are. What is the answer, guys? Mx square by
Mx square by
that's what it
3.
is. Please solve. If you are solving, it is easy. If you're not, it is not. You have to work very carefully. So triangle already we have solved axis of rotation in towards the x-axis and y-axis. Do you remember everybody? Yes or no?
Yes.
Yeah. That all the formulas you have to remember, guys. If not, it is very, very tough. It is not easy at all. Please remember. Understand, Mr. Kadir? Narayan? So both the sides x only. So if you draw the diagram very beautifully. So again I will draw. So this also x lamina, triangular lamina, and this is also x. Okay. So you can find the moment of inertia and z-axis. So if I make into that x means into, dot means outside of the page. Into the page and out of the page. Okay. Are you clear, girls? Ishali, understood?
Yes, sir.
Aswita? So that is what it is. So
Yes,
this already we have done. So I is equals mh square by x. So this is what about perpendicular axis theorem. So now we are going to start parallel axis theorem. So remember, parallel axis theorem means the most important thing is COM. What do you mean by COM, everybody? Yes, please. Center of mass. So parallel axis theorem. So this proof also I will teach you and then only will continue. So parallel axis theorem. So the most important thing is COM. Center of mass is very, very important while you are studying the parallel axis theorem. So let me take some random object. Okay. Now we all know that center of mass is located. Just imagine. So this is what everybody? COM. Okay. Center of mass. So where axis of rotation is passing, you can choose any random body. No, nothing is there. Now having a mass is how much, guys? Having a mass is how much? Yeah. So now I'm giving the axis of rotation. See, this is center of mass and I'm giving the axis of rotation is this. This is the axis of rotation of a body. Now, definitely there will be, this both are parallel or not? Do you all are experiencing both? See, this is the moment of inertia through what, guys? Center of mass. And this is the moment of inertia through what? Axis of rotation. Axis of rotation. Are you understand, Mr. Udreswa? This is moment of inertia of axis of rotation, and this is the moment of inertia of center of mass. Now both are what? Everybody, parallel or not? Respond, everybody. Parallel. So the moment of inertia of axis of rotation, moment of inertia of axis of rotation, I is equals to moment of inertia of center of mass plus ma square. This is only called as parallel axis theorem. Please learn this formula. What do you mean by A? Distance between the two. So set moment of inertia at center of mass plus ma square. That is only called as, what is that? Parallel axis theorem. Clear, brothers? Understand? Girls?
Yes, sir.
Yes. So what is the conditions required? So both axes must be what? Conditions required. Both axes must be what? Center of mass axis and axis of rotation. Both must be? Yes, please.
Parallel.
Two axes must be parallel. Next. One axis should pass through the what? One axis
Center.
must be passed through the what? Everybody. One axis must be passed through COM. Means what? Center of mass.
Center of mass.
Next. A is the what actually? Perpendicular distance between what? Perpendicular distance between what, guys? Two axes. Understanding? So perpendicular distance between two axes is only called as A. Till here, any doubt you can ask me. So these are the required conditions for parallel axis theorem. Anything doubt you can ask me. So we are going to prove it now. So let us prove and we can verify. So for proof, you can make it. So little complicated also. So you have to observe. So let me take some random shape now. So who is having a COM? So this is only COM. So one axis of rotation is passing through the center of mass. This is what is called as moment of inertia through center of mass. Now let me take the original axis of rotation, I is passing. So this is what is the axis of rotation, I. So we all knows that what is the I formula, everybody? I formula is equals to what? Center of moment of inertia of, through center of mass plus m a square. So this is what is our formula. So let me choose a particle. Total mass is m. Total mass is m. This particular particle I will choose. What is this mass? Everybody? You also respond. dm mass, which is r meters away from the COM. R meters away from the COM. That's all it is. Now, what is the moment of inertia of this particular particle at the COM? Anybody? From the COM, what is the moment of inertia? Yes, Rudeshwa. dm and the distance is r. dm r square. Now, what is the moment of inertia of this from the axis of rotation? Axis of rotation, this distance is a and this distance is r. So what is the axis of rotation from the I? Anybody? What is the moment of inertia from the axis of rotation? Everybody, which is equals to dm into r plus a whole square. Will you all agree with me? Respond, guys.
Yes, sir.
That is what. So now this is for one particle. Like that, many particles are there. So which phenomena will apply? Integration. So which is equals to dm, this one, a plus b whole square. So r square plus a square plus 2ra. So if I apply it, I'll get what? dm r square plus dm a square plus next one 2ra into dm. Am I right? Dm into 2ra. Is it okay, guys? All of you? Yes. So now I will apply the integration. So integration of di, integration of this one, and integration of this one. Now, all of you check it and let me know, everybody. So integration of di, what is the answer? Integration of di, I. Clear? Yeah. Integration of dmr square. Dmr square means only called as what? Everybody. Yes, please. Moment of inertia through what? Center of mass. Will you all agree with me? Please respond, guys. Yes. Next, integration of dm. What is that? Integration of dm. Many times I have taught you till now. Summa, total mass will come. dm. And a remains constant. A is constant or not? Everybody. A remains constant or not? A is constant. So a square is a constant. So integration of dm what, guys? Integration of dm what? M. Next, here also, a is constant. So now, a I will take it outside. Next, you see, Integration of dm into 2r. Okay, 2 is also constant. Integration of dmr. Will you all agree with me? Please respond, guys. Integration of dmr. Okay, Ra? Yes?
Yes.
Yes, sir.
Now let me see what will happen. Sir, we know the formula. What is the formula, everybody? I is equals to ICOM plus MA square. Okay, till here is okay. But what about this term? So let me see what it will become. That is only very important. So we are having extra. Now if you all observe that, so we are having integration of DMR. Let me multiply both numerator and denominator with the M. Both numerator and denominator I will multiply with what, guys? Everybody?
Yeah.
Yeah. Now, all of you observe very carefully and tell me, this DMR by M is something. Anybody can tell what is that? DMR by M, which is something. Yes, Mr. Udreswar? That is only actually center of mass. Am I right or wrong? Yes or no? Verified the total mass. Total mass means that is only correct. Am I right, guys? DMR by M.
Yes.
Yes. So DMR by M means it is the center of mass. So center of mass means what is the X and Y values? Pradosh? Origin. It is origin actually. So origin means what is the X and Y values? Anyone? Center of mass. What is the origin value? 0.
0.
So 0, 0. So we all knows that R at center of mass is equals to what is that? M1 R1 plus M2 R2 plus M2 R3 plus and so on divided by total M. That is only this one. So we all knows that integration of DMR divided by M at the center of mass will become what? Will become what? Everybody?
0.
0.
That is only so integration of DMR will become 0. Understanding all of you? So what is remaining? I is equals to center of moment of inertia at center of mass through center of mass plus MA square. This is how the proof will come for parallel axis theorem. So parallel axis theorem means moment of inertia through axis of rotation is equals to moment of inertia at center through center of mass plus MA square. So these parallel axis theorem is applicable for all the things 1D, 2D and 3D. So everything we will study, every example we will study. So, and you remember it is perpendicular to two-dimensional object. Perpendicular axis is perpendicular to two-dimensional object. Okay, that is what. Now let us solve one question now. So what the question which we have already studied. So let me take a glass rod or a rod. So rod means one-dimensional, two-dimensional. We all knows that rod. We have taken as a what? One-dimensional. Who is having mass M and L. So now what is the moment of inertia when it is passing through the center of mass, Mr. Pradosh? Moment of inertia through center of mass. We already studied. First thing we studied in the moment of inertia case, moving objects. Or through COM, what is the moment of inertia, guys? Respond. You already studied.
0, sir.
Hey, through COM, man, check it everything. What is the moment of inertia? Z-axis is passing through that. Check it, verify. ML square 12. Enna, Pradosh? Forgot
Yes.
perpendicular to plane ML square by 12. Now we want to calculate what is the moment of inertia at this corner. This is axis of rotation. We have to calculate it. Now you tell me this distance will become what? Everybody? Total is L. This will become what?
L by 2.
L by 2. So I is equals to center of mass plus MA square. Clear, Pradosh? So A become L by 2.
Yeah.
Understand?
Yes, sir.
Check it, everything. So moment of inertia through center of mass, ML square by 12. Aswita, understanding? Girls, Manya and Samya. A means what? A means L by 2 whole square. So which is equals to ML square by 12 plus this one, ML square by 4. So what is the LCM? Everybody? LCM is how much? LCM is 12. So which will become ML square plus 3 ML square, which is equals to 4 ML square by 12. 4 ones are 4 threes are. What is the answer, guys? Everybody?
ML square by 3.
Yes. ML square by 3. That is what it is. So please do it. So this is for one-dimensional one. Do you all understanding? Girl? Understanding? Meenal? Isali? So that is one.
Yes,
So
sir.
one-dimensional one it is. So axis of rotation through center of mass, we knows that. Now it is at the last I. So the distance between them, that is a perpendicular distance only A. A will become what? Total means L by 2. Sorry, L, and this half means L by 2 only. So
L
that
by
is what we want to do it. Any doubt, anybody can ask. Clear?